time, yes! Happy lesson time. Here we go. This is where we put it all together. We take everything we've done with decimals so far and start applying it to some word problems. And that's always the way we do it, right? As we go through these topics and modules, the ultimate goal is that you can apply this sort of knowledge and understanding and calculation and logical mathematical ability to real-life situations, such as word problems with addition of measurements. Measurements we'll be dealing with, okay, in decimal form. First, we're going to do kind of an extensive warm-up here. So put your patience socks on and stick with me through this extensive warm-up because, again, we're going to be using everything we've learned here in Module 6 and these word problems. So we kind of have to kick in the mathematical thinking here. Let's start off with the thing I love to do. Yes, 1 dime is how many cents? 10 cents. Remember, we're relating decimals to money. 1/10 is 10 hundredths. I want you to remember that cent right there means hundredth. Excellent. 2 dimes is 20 cents. 3 dimes is 30 cents. 8 dimes is 80 cents. You guys just got so in the flow there. 10 dimes now is $1, right? Okay, so this would be saying 10 tenths is 1 whole. So then 20 tenths is 2 wholes. 20 dimes is $2. We see? Yes, okay. 1 penny now. Let's go over to penny land. Is 1 cent. 1 penny, 1 cent. 1/100th is 1/100th. It sure is. Okay. 2 pennies is 2 cents. I almost said 3, but no, it's 5 pennies is 5 cents. 9 pennies is 9 cents. Easy so far, all single digits, right? Okay. Now, let's take that mathematical understanding of the value of coins, dimes and pennies, for example, and put it together. 4 tens plus 2 ones is not going to be 6 anything, is it? No, because these are different units. So how do we put this into standard form? 40 plus 2. See that? Good. Now we can add, it is, of course, 42, which is the answer, if you know what I'm talking about. 4 tenths and 2 hundredths. See, now this is different, but there's a similarity here. It's almost like the decimal point is a double mirror on infinity stretching in both directions. Can you hear my brothers and sisters? Yeah, so we have this parallel here between tens and tenths and ones and hundredths. They're not the same thing, but it's a parallel. 4 tenths and 2 hundredths. Well, 4 dimes and 2 pennies, right? So 4 tenths, 2 hundredths would be 42 hundredths. See? 40 plus 2, 42. 4 tenths, 2 hundredths, 42 hundredths. Great. And I hope we're all getting to the point where we can look at this in tenths and do that whole operation of conversion to hundredths, just boom, like that in our heads. That's the goal. We want to be able to look at this and say, yeah, it's 42 hundredths without saying, okay, 4 tenths times 10 tenths is 40 hundredths, all right? We know that's what's happening behind the mathematical scenes, the curtains, so to speak. Now, let's take that same example and write it in fractional form. 4 tenths plus 2 hundredths is, 42 hundredths. It's the same thing. 8 tenths plus 3 hundredths. Same idea, isn't it? 8 tenths plus 3 hundredths. 8 tenths plus 3 hundredths in fraction or decimal form is 83 hundredths. 83 hundredths. Yes, all right, how about this? 2 tenths plus 13 hundredths, yes, is a little different. We can't just smush those numbers together and call it 213 or something like that, or even 15 something, right? That's not happening. Okay, we have to think about this a little bit. Write it out in decimal form and fraction form. 2 tenths plus 13 hundredths. 2 tenths plus 13 hundredths. Now we can see the 2. Yes, this is 1/10. This one, that's the value of that 1 is 1/10, right? So it is, the 2 tenths and the 1/10 is 30 tenths, with the 300ths. It's a way of thinking about it. So 3300ths. We see that because this is an essential point to get everything else we're going to do later. For example, right now. Okay, 5/10 plus 30/100ths. Write down decimal and fraction form. 5/10 plus 30/100ths. 5/10 plus 30/100ths. Yes, you see this one? This one's a little more straightforward. 80/100ths, 80/100ths. Good. All right, and now we could also write that as 8/10. You see, we can simplify that there fraction, and we can say that, hey, 80/100ths is the same thing as 8/10. 80 cents is 8 dimes. Yes, sir. All right, 4/10 plus 40/100ths. Ooh, yeah, there is a funny thing about this one, isn't there? It's kind of weird, 40/100ths. So, again, refer back to money. 4 dimes plus 40 pennies, that's 40 cents. And that's 40 cents. Ah, when you think of it that way, yeah, 40 cents plus 40 cents, or 4/10 plus 40/100ths, we see that it would be 80/100ths, which, same as last one, we can simplify to 8/10 in both cases, decimal and a fraction. All right, 8/10 plus 37/100ths. What makes this one interesting is the first one where we will supersede. Yes, we'll go over 1 in our value here. So to write this out in decimal and fraction form, 8/10 plus 37/100ths, 8/10 plus 37/100ths. And you can even sort of mentally, visually say, this is tenths and this is tenths, so that's 11/10, isn't it? So 117, so 117/100ths. You see where I'm getting that? Good. Which is, and you see already here in the decimal form, 1 and 17/100ths. Exactly, so as a mixed number, it would be exactly that, 1 and 17/100ths. We're decomposing the 100/100ths out as one whole, leaving the 17/100ths. 1 and 17/100ths. Kablamo. All right, now let's move on. We are going to write these in first simple expanded form, and then in the expanded form with multiplication, both decimal and fraction. Okay, so we have 30, right, plus 6 plus 7/10 plus 9/100ths. Okay, so now the 30 is 3 times 10. 6 is 6 times 1. Watch that one, it can be tricky. 7/10 is 7 times 1/10. 9/100ths is 9 times 1/100th. Okay, and now in fraction form, remember, everything's the same except, right, the decimals are written as fractions. So 3 times 10 plus 6 times 1 plus 7 times 1/10 in fraction form, plus 9 times 1/100th in fraction form. Beautiful, let's do another one. 41 and 25/100ths. 40 plus 1 plus 2/10 plus 5/100ths. Ignore that. And now in multiplication form, the 40 is 4 times 10. 1 is 1 times 1. 2/10 is 2 times 1/10. 5/100ths is 5 times 1/100th. Very good. Now in fraction form, it's going to be the same thing, right? But different in that it's fractions. So 4 times 10 plus 1 times 1 plus 2 times, again, we'd say 1/10, but write it in fraction form, plus 5 times 1/100th in fraction form. Yummy. Delicious. Now we get into it. So this is the problem set. This is the problem set. We're doing the problem set together here, okay? And I can't recall. I think I don't do all of them, or maybe I do, to give you a little bit to do on your own. But of course, you always have the exit ticket and homework. So let's look at some word problems here, okay? So again, I hope you have your patience socks on, because I am not going to rush through this, because you really got to understand this. This is the culmination of all of Module 6. So let's do this slowly, carefully, thoughtfully. Amen. All right. Barrel A. So once again, Hank was up late writing his Eureka math word problems, and he was exhausted. It's like 1 in the morning. He's like, I gotta go to bed. I gotta write one more word problem. Maybe I could do something about Susie's knitting a scarf for Marcy. No, it's too complicated to have a storyline. Barrel A, barrel B, they got water in them. Like we had beaker A and beaker B, remember before? And this actually, for a barrel is a substantially large container, right? That's a vessel of some quantity. And 2 7/10 liter is not a lot. You know what a 2-liter bottle of soda looks like. So these barrels have almost nothing in them. Anyway, I've picked on their problem enough here. Okay, let's draw a tape diagram. Barrel A has 2 7/10 liters of water. Barrel B contains 3 9/100 liters of water. Together, how much they contain? We're drawing one tape because there's no comparison here. It's when we have comparisons that we need to draw separate tapes to keep our heads straight. All right, so one tape, we're putting them together. W is for water or whatever. All right, and what do? Yeah, we're putting them together. We're adding. I can't make this any more complicated. So 2 7/10. Right, let's put that in a fraction form the way we've been doing. 2 7/10. Right? And, yes, why did I do this? Because barrel B there, the exalted barrel B, which is not a rain barrel, is in hundredths. So I want to put this in hundredths as well. And barrel B is 3 9/100. Fraction form, 3 9/100. Yeah, same thing. Okay, now I can add these together, right? So now I'm going to do 2 70/100 plus 3 9/100. 2 and 3 are 5. 70 and 9 are 79/100. Notice this is the first one, so it's kind of straightforward there. Right? There's no conversion at the end here. That's our answer, except that we were asked the question in decimal form, so we should answer in decimal form. 5.79 is how we'd write it. The barrels contain 5 79/100 liter of water. Notice that liters is written with a capital L to distinguish it from a 1. All right, so that was the easier one. They get more difficult. Again, check your socks. Here we go. Alyssa, she's running a distance of 15 8/10 kilometers 1 week and 17 34 kilometers the following week. So how far did she run in 2 weeks? Oh, okay, so kind of like barrel A, barrel B, we have a little bit more of a story here. She's running, and that's actually a decent amount of running to do in a week. We're going to put the 2 weeks together. So again, one tape. There's no comparison going on here. One tape. R is for run, Alyssa, run. And we're going to put the 2 together. Same procedure as in the last question, isn't it? Yes, all right. So 15 80/100. Yes, you see what I did in one step there? Okay, that 8/10 is 80/100 and converted to fraction form. 17 34/100. How can I put these together? Well, there's a couple ways you can do it. Here's how I decided to do it. 15 and 17 are 32. All right, so just do that as a first step. Keep the 80/100 and the 34/100 as they are. And now let's put those together. What do we get? 80 and 34? Yes, very good. So it's 32 and 114 hundredths kilometers. Yes, and we can pull out the 100 hundredths, which will be another 1 whole. So 32 plus 1 is 33, leaving 14 hundredths. So there it is. See, there's the 1 whole, and leaving 14 hundredths. So 33 and 14 hundredths kilometers. But again, we were asked the question in decimal form, so our answer in our statement will be written also in decimal form. So Alyssa, big runner that she is, 33 and 14 hundredths kilometers in 2 weeks. Go Alyssa, you're running. Let's move on. Apple orchard. Now, okay, so now this one is going to step it up. It's been pretty much single step questions, just adding, although we had additional steps to make that addition happen. But now we have to think a little bit further. If you simply take these two numbers and add them together, like if I were writing a quiz on this, multiple choice, the first wrong answer would be, yeah, just add these two numbers together, and that would be your first incorrect answer. So pay attention here. An apple orchard sold 140 5/10 kilograms of apples in the morning and 15 85/100 kilograms more, keyword there, apples in the afternoon than in the morning. So that much more. That's not the total they sold in the afternoon, that much more in the afternoon than in the morning. The wording's important here. How many total kilograms of apple were sold that day? So again, we are putting two things together. How do we have a comparison here? Yes, to say this is more than that is comparing, yes. So we have morning and we have afternoon. Morning, 140 and 5/10. Afternoon is that plus the additional amount. And our bracket indicates, hey, we want to find the two of them together. So let's do that. So let's first find afternoon, 140 and 5/10 plus 15 and 85 hundredths. Okay, so 5/10 is how many hundredths? 50 hundredths. Okay, so when we put those together, we take the 140 and the 15. Let's just add those. 155. 50 hundredths and 85 hundredths now. I would mentally split the 15 off that I need to get this to 100, right? And that's 35, so 135. Good. 155 and 135 hundredths. Of course, yes, what can we do? We can decompose out 100 hundredths, which is an additional 1 to the 155. So 156, and what was left here? 35 hundredths. 156 and 35 hundredths. Now, remember, that is wrong answer a numero uno. Right, because that just gives us the afternoon. The question is the two of them together. So now we still need to add in yet another 140 and 5/10 kilograms. And by the way, another way to do this example would be to add the two 140s, 0.5 together first, and then tack this on, which actually I think might have been a little bit easier, but why do things the easy way? All right, so 156 and 35 hundredths plus 140 5/10. Yeah. Breathe. Okay. Yeah, remember, next one's going to be more difficult. All right, so let's add the whole numbers together. 140 plus 156. So you can break this down and do it in your head. 100 and 100 are 200. 40 and 50 are 90. And then we have 6. So 296. And of course, we'll want to rewrite the 5/10 as 50 hundredths. So 296. And then we have our fractional parts. 50 hundredths, 35 hundredths. Oh, okay, all right, that's pretty straightforward at least. Total of 85 hundredths, so 296 85 hundredths, because we don't have to decompose anything out of there. Then all we need is a happy little statement, because that is our answer, right? That's morning plus afternoon, saying, hey, that apple orchard there sold, putting it back in decimal form, 296 and 85 kilograms of apples. Okay. Before we go on, you might want to go, take a little break, pause the video, water the plants, brush your dog's teeth, pet your cat, stare at the fish, whatever it is, okay? Because this one is a little bit of a doozy. We have 3 runners running a relay race, and before we even look at these, stop and think, because I must admit, sometimes get confuddled on when they ask running race questions that the winner or the fastest person is going to have the smallest number. Because in most athletic events, more is better, right? You have a higher score, you win. In running, it's the opposite. The lower the number, in golf as well, the lower the number, the better. Okay, so the final runner, for some reason working backwards here, because he happened to be the fastest, he ran 29 and 2/10 seconds. Okay. Middle runner was 1 and 89 hundredths seconds slower. Now when you think slower, okay, so picture mentally that clock is running 27, 28, 29.2, here comes that first fastest guy, and then it's still going. That clock is still going, and then the middle runner. Okay, so you see slower means more time. So if we subtracted there, we would be incorrect. See how that works? All right. And then the starting runner's time was 9/10 seconds slower than the middle runners. So that, yes, would be, so we're going to add on this and then add on this. But then the question is what's the total time for the team? Because it's a relay race and Yeah, I'll assume you know, but I'll explain anyway. So it's run in 3 parts in this case. So they have a baton and they hand it off first runner to second runner to the third runner, okay? So you compile the times together. All right, yikesy. Here we go. So the final runner, him we know, or her. Again, yeah, Hank was a little tired here. Didn't bother giving them names. 29 and 2/10 seconds. Middle runner is going to be that plus the 1 and 89 hundredths. Starting runner is going to be the middle runner plus another 9/10 seconds. Okay, see, so all together there. See how this works? All right, now this is getting kind of crowded, so I'm going to swoop that up. We want to find the whole thing together, of course. I'm going to swoop that up to the corner so we have some space to work here, because we have a lot of math to do. Remember, patience sucks. I think the easiest way to approach this is to do, we can look at this and say, hey, I have 3 of these 29.2 second blocks in my tape diagram. And by the way, this is why teachers, like me and your teacher, have you draw the tape diagrams so you can actually see what's going on and know that you're doing things correctly. It's not just like for the sake of doing it. So I want to add together the big bits here. I'm going to call these 3 the big bits. And then I have these 1, 2, 3 little bits. So I think it's going to be easier here to add together the big bits and then the little bits and then put the big bits and the little bits together. So that's how I'm going to do it. You could do it other ways. All right. So 3 times 29 and 2/10. And notice I converted, yes, the 2/10 to fraction form. Well, 3 times 29, you can actually do that in your head. Because you can do 3 times 30 is 90. And then subtract the 1, 2, 3. 90 minus 3 is 87. Okay. 3 times 2/10. Yeah, 6/10. We've done that kind of thing. So 3 times 29, decomposing it here for you step by step. 3 times 2/10. That's 87. That's 6/10. Beautiful. So that gives us the big bits. See, that's why I broke it out this way. It's a little easier. And then we have the little bits. We have 1 and 89 hundredths, 1 and 89 hundredths, and 9/10. We want to put those 3 together. Convert the fraction form. 9/10 is how many hundredths? Good, 90 hundredths. So putting these 2 together first, we have 2, 89 plus 89. You can actually, here I'm going to back that up so you can't see it. 89 plus 89, again, I can use that same add and subtract mental math. Isn't it easier to do 90 and 90 is 180, and then subtract the 2 I added in there. 2 back from 180 is 178. So 2 and 178 hundredths plus 90 hundredths. Zooey mama! We've only just begun. I told you, this is a tricky one. All right, so if we decompose out the 100 hundredths here, leaving the 78 hundredths, so that's 3 and 78 hundredths that we still need to add to the 90 hundredths. Okay, so 3 and 78 hundredths plus 90 hundredths. All right, so, and again here I would use that mental math strategy of saying, I need to scoop out 10 here to make a nice even 100, and that would be 68, so 168 hundredths. You see that? So there's the 10 I need to make the one whole, leaving 68 hundredths. So altogether, there's 1 with 3 is 4 and 68 hundredths. See that? We've done this before. Okay, good. Now that's just the little bits. So I need to put the big bits and the little bits together to get all the bits. The big bracket, the question mark. All right. So 87 and 6/10 plus 4 and 68 hundredths. Woo! So 6/10 is how many hundredths? 60 hundredths. Okay, so when I look at this, though, another way of approaching this is to say, I have, wait, go away. All right, I have 6/10 there, right, and 8 hundredths. So I can bust out 4/10 to make a nice even 1 with those 6/10, leaving 28/10. There are different ways of doing this, okay, but this is one way. So what that does then, I say 87 plus the 1, made of the 6/10 and 4/10, plus the 4. 87 plus 1, 88, plus the 4, 92, and what was left on my fraction? 28 hundredths. Now you could just mash these together and get 91 and 128 hundredths, and then decompose out the 100 hundredths. Perfectly fine. Neither way is better, just two different ways of doing it. And now that is, and you want to check before you say this is my final answer, yeah, I have the 3 big bits, and I have the 3 little bits. There's the big bits, there's the little bits, put the big bits and the little bits together, I get all the bits. Now I just need to write that back in decimal form. 92.28 is how I'd write 92 and 28 hundredths in a statement. Yes, and if you want to be super fancy, like me, I'm so fancy, you can decompose out from those 92 seconds. Yes, 1 minute is 60 seconds. So 1 minute and 32 and 28 hundredths seconds. Cha-ching! Wow! How's that? Bask in the glory. Oh boy. So that problem set then is done, and the exit ticket just has a single question here, and this is not one of those super tricky ones. This is just, hey, putting together 2 amounts she ran. And then of course, what do? When you get to the homework, hop over to my homework time video, and I'll go through each question step by step with you. And this follows the same progression. This is just crunching some numbers, okay, and then, yep, this is just putting 2 parts together. And then this one has that same little trick where it's this much, and then this one's this much more, so you'll draw 2 separate tapes here. See, back on numbers 1 and 2, you're just drawing 1 tape because you're just adding together 2 things. 1 tape, you're adding together 2 things. Here it's a comparison. And again, here we have another relay race. They want those relay races. Nice job, Hank, writing these. Give them names this time, though. Max, Maria, and Armin. Nice job. And it's love that it's a co-ed relay race team. So we need, again, here, same idea here. This one's slower than this one's slower than this one. What's the total time? And wow! Who needs a nap now? Yeah, that was a brain stretcher, but it's good exercise for the brain. So take that nap if you want, go pat the cat, and I will see you again next time. It is once again lesson time.